Welcome back to the KE Learning DIY Organizational Development course. We shared a foundational breakdown of the first building blocks in the process of actualizing a data-driven organization in Chapter 1.1, where we detailed all the core functions and sub-functions that typically make up the shape of an organization, from the customer management and operations function to the business operations function. We then followed that up with a conceptual framework of how to approach an organizational design exercise, where we detailed the key components, steps, and outcomes of an organizational design process in Chapter 1.2. These key components include people, a core input to any organization, the key organizational design considerations of which include skills, competencies, and leadership, process, the key organizational design considerations of which include process optimization, as well as process enablement, systems, key considerations of which include system infrastructure, system integration, as well as system architecture optimization, and lastly, data, the key considerations of which include data modeling and usage, data management, as well as data storage and security. We also highlighted some of the key outputs of a well-designed data-driven organization which is free of the silo effect, where each function and sub-function moves to the beat of the same drum, pursuing the same organizational goals and working towards the same overall strategic objectives. We're now going into Chapter 2, where we're going to break down the framework with which we're going to perform our DIY organizational design process. Let's get going. The first component we deal with as a starting point is process. The three main activities of process as a component of organizational design are process mapping, process optimization, as well as process automation. There are a number of sub-activities that make up the actual steps of the operational architecture construction. The collection of information is the first step, which serves to ascertain the current form of working, with the objective of unearthing that which works and that which does not in the current way of doing things. Outlining this information will involve process mapping, where, in addition to unearthing what is working and what is not, optimization and automation opportunities will be identified and assessed in terms of what it would take to implement these optimization and automation opportunities, and if such an implementation is actually possible and feasible in each case. Once all of these have been worked out, a final set of optimized process maps that are aligned, optimized and autonomized where possible can be packaged. The activity-level steps of process mapping, optimization and automation involve identifying the trigger, which is the why that necessitates the performing of the process in the first place. For example, in a normal life setting, a triggering situational context might be that of a lost dog, necessitating a process of searching for the lost dog. This is followed by mapping the steps of the process, which in the lost dog context would perhaps involve making flyers, going to neighbors door to door, pinging the electronic dog collar if one exists, and so forth. Identifying the key actors at each stage of the process is the next step, essentially the who is doing what of the process, followed by identifying the tools and systems at play in each step of the process, along with the information necessary to perform tasks at each step. The origin of every piece of this information has to be noted, be it from other actors, systems or tools used within or outside of the process in question, along with all the actors feeding or extracting this information from outside the process. The activity ends with synchronizing all the processes, sub-processes and tasks to fully make up the foundation of operational architecture of each of the functions and sub-functions, flowing seamlessly through overlaps and integration points from sub-function to sub-function, as well as from function to function. For example, if we take the customer management and operations function as an example, and then take the leads management sub-function as an example, then we'd have to develop the process component with the core objectives of leads management as input. These objectives would form somewhat of a guiding light to the activity of mapping, optimizing, and automating processes for this particular sub-function. For example, using our data-driven value map as a guide, product and service personalization would be a key objective for leads management, because potential customers are likely to convert to monetization if they feel the service or product closely matches their needs and what they are particularly looking for. This personalization consideration would be at an audience level in the process of managing and driving the lead towards monetization. Customer segmentation is also a key factor, leads management-wise, because not only does it determine how the lead is managed and converted, but also who gets to manage the lead in most contexts. Sometimes, most times, especially in the context of B2B, leads management would involve a fair bit of customer value management in the process of converting the client or closing the deal, so this has to be captured in the leads management process, as well as associated policies that govern various scenarios of the conversion-related customer value interactions. These lead conversion-related customer value offerings are likely to be comprised of a large chunk of conversations or considerations about pricing. Segmentation means that there are likely going to be different types of offers for different types of customer segments, with different customer value options and with offerings at different pricing levels, all of which might be organized in a tiered fashion. Aligning all of these considerations, or rather, strategic objectives at different levels of the organizational business architecture, and integrating them within the leads management sub-function in a way that is optimal and derives maximum value means a fair amount of automation will be part of this process for it to truly work, and that's where AI comes in. Similar to a human-dependent process, an AI-heavy process will also need to have the process mapped and defined in terms of triggers, actors, which may be systems, APIs, or other AI models, as well as capturing the origin, movement, and destination of data across the entire process. We'll talk about this in greater detail when we apply the framework we're currently building to our case study, which we'll unpack in Chapter 3.